applications of Newton's law, there's that one thing that is most important. And if you miss that concept, this will affect everything. What is that? The most important part in Newton's law applications. I don't know. A free body diagram. If you are struggling to indicate all the forces that are acting on a certain object, there's no way you're going to get your calculations right. I'm not sure if that makes sense. So what I'm trying to say is that to master Newton's law, you need to understand a free body diagram. Né? So we have a statement here that says we are given two wooden blocks that are pushed up and inclined at an angle of 20, né? With a force 94 newtons parallel to the incline to block B. Okay, so block mass A. Okay, so now we have the mass of block A. It's given as 5 kg. And then explains a frictional force of 18.4 newtons and block mass B. This one is 8 kg and it has a frictional force of 29.9. Right. So we'll come back to analyzing the question. We'll come back to that part. Don't worry. So the first question says, state Newton's third law in weights. Newton's third law in weights. When an object A, this has to do with force reaction reaction force. Né? When object A this. Okay, when object A exerts a force on object B, we say that the object B will simultaneously exert an opposite directed force of equal magnitude. Equal magnitude. If you take maybe a ball, you hit the wall with the ball comes back in your direction, you see? So the whole exert an equal force, but in an opposite direction. So equal magnitude on A. Okay, so that was Newton, third law. Draw a label free body diagram of all the forces acting on block B. So I think it's always easy when you start with the vertical forces. Né? So block B will have a normal force acting up, which should be perpendicular to the surface, right? And then the very same block B will have a weight. This one is always acting down. So I'm not going to include components, understand? So I won't include component, and now look at where the applied force is pointing. So the applied force is pointing up. So far I have three forces. The applied force, this is my F applied. And then in that direction, we have the normal force, that's my Fn, and then going down, this is the weight. These are three forces that are acting. And then now, since the equation, the question is 5 mark, né? You need to have 5 forces on your free body diagram. So we have 2 forces that oppose the direction of the motion. In fact, we have 1 force that opposes the direction of the motion, which will be friction. So friction will go down, friction will go in this direction, then there's that one friction. This is Fk. Né? So there's one force missing without talking about the what is this? Without talking about the components like the Fg parallel and the Fg perpendicular. There's that one other force that is missing. Do you know which force is that? Looking at these two blocks, there's that force that will go down. Exactly, the force that A will exert on B. So since B is making A to go up, A will exert an equal force in an opposite direction. So going down, we're going to have a force. So I'm just going to indicate this with a different marker. We're going to have a force that will move down, and we're going to call this the force A on B. It will go downward. Né? Okay, next question. They want us to determine the coefficient of kinetic friction between the block and the surface in the incline. The coefficient of friction, we can use A, we can use B. They'll have the same coefficient of friction. Eh? You can use object A, you can use object B. So now, remember, the kinetic friction has the formula, has the following formula, like saying Fk, it's equals to UK, which is the coefficient, times the normal force, which is Fm. So the only thing that we need to do, look at this. I'm looking for the coefficient. I'm given, this is given, right? So you just have to indicate which block are you working on. You can do for A, you can do for B. Let's say I use block A. So if I use block A, they said block A, it experiences a frictional force of 18.4. So I'm going to write this down and say for block A, has the Fk of 18.4 newtons. Then, do we have normal force? We need to find the normal force first. So to find the normal force, you need to indicate the, look at this. Normal force, remember, most of the time we used to say normal force is equal to mg, right? It's equal to the weight. But this object is uninclined. It's not just the weight, but it's the Fg perpendicular. Remember, this is like saying Fn is equal to Fg, right? But when it's uninclined, if this is your normal force, the force that opposes the normal force is not Fg. Can you see that? Fg is going down. So the force that opposes is the one that is Fg perpendicular. And Fg perpendicular, that's mg, the cos of theta. So just a quick exam, tip. Né? If we are uninclined, you just add perpendicular, then you add the cos theta. If you are not uninclined, remove the green part. Perfect. So now we know that normal force will be Fg perpendicular. So what I'm going to do, I'll come back on my equation and substitute and say my Fk will be UK times the normal force is Fg perpendicular. It's going to be Fg perpendicular, which gives us our Fk to be UK. Then Fg, that's mg, the cos of theta. Then now we can substitute and solve for the coefficient. My Fk is 18.4. UK is what we are looking for. The mass, we are using the block A, which is 5. And this is 9.8. The cos of that inclined, which was 20. So to make UK subject of the formula, you can divide both sides by all this part here. All this part that you see here. You can take this part, divide both sides before maybe putting it on the calculator. And what do you get as your coefficient? So I'm going to divide I'm gonna say therefore my UK, it will be 18,4 divided by 5 into 9,8, and then the cos of 20 degrees, and then you'll find your UK and see what is that equals to. This should be 0,4. Is that what you got? When we round it off to one decimal place, it's 0,4, right? Okay. State Newton's second law in weights. So Newton's second law, that's F net, it's equals to MA net. That's Newton's second law. So you can stay looking at that formula. So we're gonna say when a net force is applied, it's applied on an object, what will happen to the object? Let's say the object that has a mass, we're saying that it accelerates in what? In the direction of the net force. But when you look at this formula, we can see that the acceleration, it's what is directly proportional to the net force. So it's directly proportional to the net force. You get it? And then and it's also inversely proportional to the mass. Inversely proportional to the mass. All good, né? Okay, and now they want us to use Newton's second law to write an expression. They don't say do calculations. We just have to write an expression in terms of acceleration and the force acting on the block. Né? Do not substitute any values. You write an expression. First thing first, to do this, remember when we started the lesson, I asked you what is the most important thing that you need to understand in Newton's law application. We said free body diagram. So they say use Newton's law to write an expression in terms of acceleration and the net force acting on what? Block B. We need F net, it applies to horizontal forces, right? We're gonna do this because the acceleration is for the horizontal forces, right? So now you're going to draw all the forces that are acting on block B, all the horizontal forces that are acting on block B. If you miss one force on your free body diagram, everything will be wrong. So that's why the free body diagram is important. So now I'm going to have the F applied going up, understand? And then we said the frictional force will go down, right? And then on block B, we also mentioned the force of A on B. Understand? So my question is that are these the only forces that are acting on B? Are these the only horizontal forces? What do you think? Just think about it. Are these the only one? Think about that one component force that is acting here on B. Perfect. The FG parallel. So the FG parallel always act down. If the object is going down, FG parallel will go down. If the object goes up, FG parallel will go down. So when you do calculations, you include all the forces. You see, when we were drawing a free body diagram in 4.2, we did not include FG parallel. It's fine. But when you do calculation, make sure that you include everything. So I'm going to take this free body diagram. Let's draw it down here. Then we can do an expression. So we set this F applied going up. And then from this F applied, we have Fk. And then we have this as the force of A on B. And then the last one we said we have FG parallel. So listen, another thing, choosing direction is also important. So I'll take up as positive. This is the direction of the motion, right? So if I take up as positive and I use Newton's law, F net is equal to MA, then you go, they say don't do any substitution, right? So you're going to take the one that is going up, which is your F applied. You subtract all the forces that are going down. All the forces that are going down. And then you subtract your FG parallel is equal to MA. So now it's either you can leave your answer like this, or you can continue and say FK maybe substitute FK. Remember we said if we go back up, what was the formula for FK? The formula for FK is UK mg the cos theta. Right? So I'm just gonna do it here. So this will be UK mg the cos of theta. UK, this will be UK mg the cos theta. And then we still have to subtract your FA on B. We still have to subtract FG parallel, which is mg, the sine of theta is equal to MA. Then you leave it like this, you get full 2 marks. Né? So if you understand how to do the expression, substitution is easy, right? Also, isolating, maybe you are trying to find the force of A on B, it will be easy. The most important part is to understand how to do the expression. If you can't do the expression, if you struggle with the free body diagram, so it's very important that you start with the free body diagram. Next question, 4.6. Determine the magnitude of the force that A exert on B. You don't have to go far because already we have this thing here on the, we have this thing on what? Remember, this free body diagram is for what? This free body diagram is for object, is for block B. So I'm going to use this expression to find this force. So I'm going to rewrite this force down and say my FA minus UK mg the cos of theta, we subtract FA on B minus mg the sine theta, this is equal to MA. Perfect. So now when it's like this, I'm going to do my substitution. This is for block what? This is for block B. Né? We are using block B. So I'm going to say the F applied on block B, that is 94. That is 94 newtons. So this will be 94. We minus the coefficient we just calculated that guy as 0.4. Né? So in fact, instead of saying, let me see, don't you think if we should just use the given force instead of doing this? Né? Because already we know what is FK for block B. We know what is FK, right? So all this, it was given up here. On the statement, they said it's 18. Oh, for block B, it was 29.5. It's given as 29.5. Okay, so now this will be 29.5. I'm going to subtract 29.5. And then minus the force A on B, it's what we are looking for, minus my FG parallel that I'm going to say this, the mass it's 8, 9.8, the sine of 20 degrees. This is equals to the mass, it's 8, but we don't know acceleration. So I think we can just try to work this thing out and see what we can get from this point. So I'm going to work out this to, what is this? Maybe if we can work out around this term here. No. On your calculator, you're gonna say this, and then with that, what do you get? Please don't make mistakes, or should we just do this together here? So this will be 94. We need to take 94, and then we're going to subtract 29.5, and then we're gonna subtract inside the bracket, that's 8 into 9.8, the sine 20. This gives us 36.69 if we round it off to 2 decimal places. 36.69. Okay, so I'm gonna take my 36.69, write it down here, and say this is 36.69. 37. Was that 37? Did we get 36 or 37? 37.69, okay. $37.69 minus the force A on B. I just worked out the like terms. This is AA. So now from this part, I can just do, I think maybe if I call this equation 1, okay, this is equation 1 because I have two unknown variable, acceleration and also what? I have acceleration and also the force A on B. So this tells me that if this was for block A, this was for block B, I need a free body diagram for block A. I need a free body diagram for block A. So if I go up on block A, I need to indicate all the forces that, the horizontal forces that are acting on block A, and which gives us do we have okay, so let me say I'm gonna have force going up. Remember, A experience a force due to B, so this will be force B on A. You understand that part? And then we know that A will also have the FG parallel acting down, and A will also have the frictional force going down. We'll also have FK. So these are 1, 2, 3 forces. So there's only 3 forces acting on this block. So I'm just going to bring them down here and create my expression. So this will be force B on A, FK, and also FG parallel. So remember, we still have up as positive. So I'm going to take all the forces that are going up, because this is F net, it's equals to MA. So all the forces that are going up, force B on A, we subtract all the ones that are going down, and FK equate this to MA. Then I do the substitution. Force B on A, it's what we are looking for. No, yeah, it's what we are looking for since the two forces are equal. I'll explain that when we get there. And this one is like mg, the sine of theta minus fk. And then let's equate this to ma. Can I do the substitutions? I'm going to say my fb on A minus the mass, it's for the 5 kg block, 9.8, the sine of 20 degrees minus the frictional force for block B. Do you still remember what was the frictional force? or 18.4. So the frictional force for block A was 18.4. So I'm going to substitute my 18.4 here, and the mass is 5A. So what I'm going to do, I think we need to work out this part on the calculator. And then let me go back this part. You see this part? I'm going to make my FA on B subject of the formula, meaning this leaves us with 37.69 minus 8A equated to the force of A on B. Okay, so even this same, we're going to do the same thing this side. Therefore, my FB on A will be equals to, let's punch that first on the calculator, see what we get. This will be 5. Okay, this will be minus into 5, 9.8. Okay, and then the sine of 20 degrees. Then we're gonna minus 18.4. This gives us negative 35.16 if we round it up to 2 decimal place. This is negative 35.16. So if we move it to the other side, it becomes 5A plus that 35.16. So now look at this. Remember, according to Newton's third law, the force A on B, it's equals to the force B on A. You understand? These two forces are equal. So since they are equal, I can take my 37.69 minus 8A, equate this to 5A to find acceleration. 5A, then minus what? 5A plus 35.16. So I'm going to group the like terms and say on this other side, I'll have 5A. The 8 comes this side to be positive 8A, and this side I'm going to have 37.69. Then we subtract that 35.16. This is 13A. And then the other side, it's 37.69 minus 35.16. This gives us 2.53. So this is 2.53. Divide both sides by 13, divide both sides by 13. This leaves us with an acceleration of answer divided by 13. The acceleration is 0.19. Okay, so this leaves me with an acceleration of 0.19. 0.19. How will this help us to find the force that they are looking for? We can use one of these formulas. We remember they are equal. We can say this force will be 5. Then where there's A, you put that 0.19. Then you're gonna add 35.16. So we just have to substitute and say 5 into 0.19. We add 35.16. 5 into the 0.19. Close the bracket, then we're gonna add that 35.16. And when you work with this type of questions, the final answer is 36.11. But remember, the answer might be difficult, might be different depending on your roundings. How did you do your roundings? So this will be, what is this? This will be 36.11 newtons. That is the force B on A, which is equal to the force A on B. So this is the answer. So as I've said, the answer might be different on your decimal. You might say maybe you get 1, 2, maybe you get something else depending on how you did the rounding. Yeah? So to be on the safe side, I think it's best if you round off to 3 to 4 decimal place and only round off to 2 decimal place on the final answer. You understand? Or avoid rounding. Like you can also avoid rounding. All right, and that's it for this one for the Newton's law. So